Alright guys, we're going to talk about coordinate proofs and going at the basics today because we'll get into some more complex examples starting next week. So, first what we'll do now is what makes a shape a rectangle. As with all my videos, feel free to pause it, think it over, maybe come up with your own answer, and then hit play to check the answers out. And if you did that, you might came up with a list similar to this. This is just some of the examples from our previous section. We talked about quadrilaterals and different characteristics. So we'll be able to translate these into our coordinate geometry section, specifically involving sides that are parallel, 90-degree angles meaning perpendicular lines, as well as opposite sides being congruent, and we can prove congruence by using our distance formula. So here's just a couple different examples of what we're going to be using today. Now, let's look at some of our first couple examples. If I was given 3 coordinates, or 3 vertices of a rectangle, how can I figure out the fourth one? Now, we might be able to just visually, almost like drawing a picture, like where does it have to go? But we want to think about this mathematically as well. Where did point D have to go? Point D would have to go here at 4, 4. But why? Well, if point D is at 4, 4, the opposite sides, CD and AB, are parallel and equal in length. As well as by putting point D here, AD and BC are also parallel and equal in length. Furthermore, we can show that side DC is perpendicular to side BC as well as to side AD, therefore forming our 90-degree angles. Parallelogram, ABCD. Well, let's think about what we know about a parallelogram. We know the opposite sides have to be equal as well as parallel. So I want those opposite sides to be congruent as well as parallel. So where does point D have to go? Well, BC, let's look at the slope for how we get to B to C. Up 2, right 2. Up 2, right 2. Well, that means from A to point D, our missing point, has to follow that same pattern, the same slope to be parallel, as well as the same amount of distance in order to be congruent. Up 2, right 2. Point D would be at the coordinate 2, 2. Right? Now AD and BC are both congruent as well as parallel. And you can count the slope between DC and AB to show that these two sides are also parallel and congruent. Our last one on this warm-up is rectangle ABCD. I'm going to leave that one for you guys, but don't worry, I'll put the answer to that or the missing coordinates. I'll leave that in the comments on our Google Classroom. All right. So now let's look at some examples that are a little more interesting today. We want to be able to prove or disprove that the quadrilateral ABCD is a rectangle given these vertices. How do we do that? There's 2 different methods of proving that something is a rectangle. Here's method 1. Method 1. Opposite sides are parallel, adjacent sides are perpendicular, and all sides are not equal. So, let's go into this and show, can we prove that these 3 statements are in fact true in order to prove that this is a rectangle? First thing we're going to look at is the slopes of the sides. This way we can try to look at almost simultaneously proving that the opposite sides are parallel as well as the adjacent sides are perpendicular. So let's look at the slope of all 4 sides. Here's how we're going to set up the slope for all 4 sides. So let's set up the slope for all 4 sides. Well, remember our slope formula. It's the change in y over the change in x. So our 4 slopes of each side would look like this. Now that we have the slope formula set up, now let's go ahead and simplify this. Our first slope, AB, would simplify to be 2 over 6, or 1/3. Our second slope, BC, would simplify to be 3 over -1, or -3. Continuing, we would get -2 over -6, or positive 1/3 again. And last but not least, a slope of -3. Look at our slopes that we have so far. I have my opposite sides are parallel. Same slope. I also have the adjacent sides are perpendicular, meaning that they are negative reciprocals to one another. So far, we have demonstrated the first 2 conditions of our method 1. The opposite sides are parallel and the adjacent sides are perpendicular. Now we have to show that all sides are not equal. Well, how do we go and show that? To show that all sides are not equal, let's look at the distance from segment AB as well as the distance of segment BC. Now these sides are adjacent to one another, so therefore they should not have the same length if they are a rectangle. If they did have the same length, well then we'd be looking at a square and not a rectangle. Here's what the distance formula looks like. Now that we have our distance formula set up, now we can look at solving this. Simplifying, 8 minus 2 squared is 36. That's 2 square roots of 4, and we get the square root of 40. This can be simplified, but I really don't need to simplify it for this purpose. Next up, we find this is 1 plus 9, or the square root of 10. Notice that these two distances are not the same. Therefore, we have shown that ABCD is a rectangle because opposite sides are parallel, adjacent sides are perpendicular, meaning they form right angles, and the adjacent sides are not congruent in length, meaning all sides are not equal. Therefore, by using method 1, we have shown that this is in fact a rectangle. Now I'm going to show you guys a second method on this next example. The second method to determine whether a quadrilateral is a rectangle is this. Method 2 says prove diagonals are congruent and all sides are not equal. So we're going to prove that the diagonals are congruent, meaning that they would have the same length. Right? Our diagonals are AC and BD. So here's what the equations will look like. Now that we have our distance formula set up, just to remind you, the distance formula is the change in x squared plus the change in y squared, all under the square root symbol. Now that we have this set up, we can calculate our distance. Well, our distance, simplifying, this is 9 plus 16, which is the square root of 25, which is 5. We have over here, this is 25 plus 0, which is also 5. Therefore, we've established that the diagonals are congruent using the distance formula. Next up, we have to show that all sides are not equal. We're going to use a similar method to what we used above by showing AB, side AB, comparing to side BC. And let's see if they are equal in length. This is our distance formulas for AB and BC. So to calculate the distance or the length of that line segment, we are simplified from here. 1 minus negative 3 squared plus 2 minus 0 squared would come out to be 16 plus 4, or the square root of 20. Again, that can be simplified, but we don't need to do it for this purpose. Underneath, we have 1 plus 4, or the square root of 5. Notice that the lengths are different from one another. Therefore, all sides are not equal. Thus, we have shown that this is a rectangle by the second method. These two methods are both valid ways of showing that something is or isn't a rectangle. We have our 3 conditions up top, more focused on the slope, or we have these 2 conditions on the bottom, which is more focused on the distance formula. Either one you can use to prove or disprove that something is or isn't a rectangle.